Alright folks, welcome to part 6 of the series, Variable Length Subnet Mask, or VLSM. So, way back in the early days, again when they realized how the internet was kind of popping up and everybody was going to use it and stuff, they realized that even SIDR by itself was not enough to save enough addresses for the entire world. And the problem is, SIDR only allows you to make equal sized networks. So I can take one network and I can divide it up into equal sizes. But what if you need a network of 100 usable IP addresses at the headquarters, and then you have a branch office that needs 50 usable IPs, and then you have a small satellite office that will probably never get any bigger, but only needs 12 usable IP addresses. So your only option under SIDR would be to take one large network and split it up into 4 networks of size 128. Well, having 128 usable IP addresses at a small, let's say a McDonald's that only needs 12 usable IP addresses, is kind of a waste of IP addresses. And you have to remember, when all this stuff was developed, the internet was very young, and you had to have an IP address typically for each person that got out on the internet, unless you were doing some kind of natting. So, and the networks, again, the IP addresses were like $25 a month, so they were very expensive. Plus, being on the internet back in the day was like $2.99 a minute. So there was a lot of cost associated with the internet and stuff. So you wanted to be as efficient as possible with your IP addresses, and that's really kind of where the concept of VLSM was introduced. So SIDR allows for a network to be divided into equal parts. VLSM allows for a network to be divided in unequal parts. So everything works the same as SIDR. You use the exact same formulas. You create the range chart the exact same way, but each subnet might have a different subnet mask. So you just stop making the range chart once you have enough ranges for the number of networks that you need. So if I'm subnetting in like a class B and I need 3 networks of 100, I would stop after the first 3 in the range chart. If I only need 1 network of 100, I would stop after I have the first range of 100. And let me show you an example of what that's going to look like. So you're going to see something like this, and you can see the subnet mask changes with each part. So this first network, 0 through 127, allows for 126 usable IP addresses, but has a subnet mask of /25. So I would go 0, and then I know I need a network of 100, so I go to 128, and then I stop, and then I fill in this top part, and there's my first network that does 126 usable IP addresses. Well, then I start all over again at this next number where I stopped and say, hey, now I need a network that fits 50. Well, I can either do 32 or I can do 64. So I do a range of 64. So I go 128, I add 64, and I get 192, then I stop. And then this network would give me 62 usable IP addresses, so the subnet mask changes. And then I need a network of 14 usable, so I get a range of 16, and I pop that in there. So it's just, we keep doing the range chart the same way, but you do one network, then you stop, then you figure out the new range, and then you figure out how many networks you need, and then you stop, then you figure out how many new networks you need, and you just kind of keep going like that. So once you figure out how to do this range chart stuff, it's very easy. Again, you're just making the range chart, you're just stopping and then coming up with a new range, and you're good. All right, so let me show you a couple examples of me doing variable length subnet mask. All right, now let's talk about VLSM, which is variable length subnet mask, meaning you're going to get different subnet masks for each subnet typically. So you'll see a question like this. So my company starts out, I got 192.168.100.0 with the default subnet mask of /24, and I have a branch office that's going to need 50 usable IPs. I have a headquarters that needs 100 usable IPs, and then I have a satellite office that needs 12 usable IPs. So they want you to figure that out, and again, variable length subnet mask is to save IP addresses and use just the minimum that you need. So the first thing you need to do is you need to organize this list by the highest and the lowest. So in this case, we need 100, and then 50, and then 12. And it works out the exact same. So first, we're going to solve for 100, and then we're going to stop on the range chart once we get as many networks as we need. So we need 1 this size, we need 1 this size, and we need 1 this size. Let's just say they have 2 satellite offices. So we need 2 this size. So we know the first one, and again I'm focusing on here. You need a network the size of 100. So we always start with the biggest and we work down to the lowest. So our host network is 2 to the y minus 2. So 2 to the y minus 2 equals 100, because we know we got to fit at least 100. So in this case, if I do 2 to the 6, it only gives me 64, but if I do 2 to the 7, that's going to give me 128 minus 2, which is going to give me 126. So you have to decide, let's say 2 to the 6 minus 2, 64. If I owe you $100 and I give you 64, are you going to be happy? No. If I owe you $100 and I give you 126, are you going to be happy? Yes. So you have to make it happy. So we know we're not going to use this because it doesn't make me happy. So 7 zeros in the subnet mask means our new subnet mask is going to be 255, 255, 255, 128, or a /25. So what's our range chart based on 128? Well, just because I know this, it's just going to be 0 and then 128. Because our range is 128. Ta-da! So then we stop. We don't go all the way down to 256. Then we just stop here. Then this is 128. So this would be 127. So this first network here is going to be a /25. And did I do a 24? What was I smoking? All right. So then we add the 1 and subtract 1 from here. So 126. And we stop, and then we just start all over again with the second one. So now we need to work out 50. So exact same thing. 2 to the y minus 2 equals 50. In that case, we know 2 to the 6 is going to give me 64. Minus 2 would give me 62. Or 2 to the 5 minus 2 would give me 30. So again, if I owed you 50 bucks and I gave you 30, you going to be happy? No. But if I owed you 50 bucks and I gave you 62, would you be happy? Yes. So you need to make them happy. Now, you don't want to make them too happy with a 7 there, because obviously then you're going to be wasting addresses. So we're going to do 2 to the 6, and we know that that gives us 64. So my new range is 64. So we just start here and we add 64, and this becomes 192. So we subtract 1 from here, 191, and we know this is going to be a /26, because now we have 6 zeros. Well, this is going to be 192, and this is going to be 255. Sorry about my writing. And pop that in there, and then this is going to be 129 through 190. All right, then we start the whole process again. So now we need to solve for 12. So 2 to what is going to give me 12? We know it's going to be 2 to the 4, because that's going to give me 16. Minus 2 gives me 14. And we know that 2 to the 4 is 16. So if I add 16 to this, I get 208. And if I add 16 to that, I get 224. Brain farted there for a minute. So subtract 1 from 224, 223, subtract 1 from there, 207. And if I have 4 zeros, then we know that the new default, or the new subnet mask is 28. And 193 to 206, 209 to 222. So there's our variable length subnet mask. We have a bunch of different networks, and we have different subnet masks going across the range chart. But we stopped at 224, so from 224 to 256 or 255, these are all free and available for other things. Now, what they typically don't tell you in a lot of these problems is, when you have networks, so in the old days, we always built up the headquarters office, but nowadays we're not really building headquarters offices anymore, like, where we're expanding. Years ago, the hospital system in this area would buy a block, and then they would, expand their hospital on that block and put new buildings and stuff up. So we're not really building large headquarters buildings anymore. Now we're expanding to branch offices. So you'll have a headquarters where the business gets its start, and then eventually it'll start branching off. And you get all these little branch offices or satellite offices, depending on how big they are, what they're calling them. Now, each one has its own router that has to talk to this router. And these small areas between just two routers need two IP addresses. So they need a bunch of /30s networks with only two usable IP addresses for these networks. You know, down here they might have 50, this might be the 12, and the headquarters was 100, and this was the other one that had 12 networks. So then you have to subnet, but you also need some /30s for these connections between routers. Does that make sense? Good. All right, let's do one more variable length subnet mask. So we start out with 172.16.00 with a /16, so we have a default subnet mask on a class B. We have a headquarters building that needs 900. We have two branch offices that both need 200 usable IP addresses, and we have a third branch office that needs 50. Now, again, the same thing, so we start with the first one, so we need to solve for 900. So 2 to the y minus 2 equals 900. And again, if you look at your powers of 2, you're going to see 2 to the 10 minus 2 gives you 1022. And then below that you get like 510. So we know 2 to the 9 is not going to be enough. It's not going to make us happy, so we need to do 2 to the 10. So if we have 2 to the 10, that's going to give us 10 zeros in the subnet mask. So there's 32 bits in a subnet mask, and 10 of them are zeros, should be minus. If there's 32 bits in subnet mask and 10 of them are zeros, then we know that 22 of them are going to be ones. So our new subnet mask is going to be /22 for the first one. All right. And then if we look at our range, we just remove this part, and our range is 1024. Now again, with class B, you can do this 2 or 3 different ways, multiple more than that, but you can, the 2 ways that I teach is you just take 1024 and divide that by 256. In this case, you get 4. Or we can just go to that third octet. We know if it's /22 that there's 1, 1, 1, 1, or there's 6 ones and 2 zeros. So if I have 2 zeros, that's 2 to the 2, that would give me 4 networks. So we could do it that way, or we can do it the long way, however you want to do it. So we knew we have a range of 4. So we start at 0, and we add the range. Then we stop because we only need 1. So remember, this is a class B, and we're in the third octet, so 0.0, 4.0, and then 0.1, 4.1, and then we need to figure out what's over here. So in this case, it's going to be 3, and that's going to be 255, because that's the last usable in that range, and then 3.254, because that's the second to last one. So there's our first subnet, and we know that's going to be a /22. Now here's where it gets weird. So now I need to solve to get 200 usable IP addresses. Well, 2 to the 8 gives me 256. 2 to the 7 only gives me 128, so that's not going to work. So I have to do 2 to the 8. So 2 to the 8 is going to give me 256, minus 2 will give me 254 addresses. So if there's 8 zeros, the new subnet mask becomes /24. And it just becomes, again, over here, so /24. So we know with that, because I'm not subnetting in the third octet anymore, the range is just going to be 1, because the /24 would be 1, 1, 1, 1, 1, 1, 1, 1. Would just be 8 ones. So I would just put a 5 here, 5.0, and then a 6.0. And then it's going to be 5.1 and 6.1. So that kind of solved that for those two pretty easily. And so this becomes 4.255. This becomes 5.255. And then 4.254. 5.254. So there's our headquarters, our 2 branch offices. Now we just need to figure out the one for 50. So again, you just stop the range chart, resolve for 50. And 2 to the y, 2 to the 6 gives me 64. 2 to the 5 only gives me 32, so that's not going to be enough, not going to make them happy. So now we have 6 zeros in the subnet mask, so the new subnet mask becomes /26. And we know the range is 64, but here's where it gets tricky. Here, now we're over in the 4th octet, that we're dealing with. So because our range is only 64, we just take 6.64 and then 6.63, and this has a /26. So at this point, we've actually moved all the way over into a class C, and now we're kind of subnetting a class C on the 4th octet. So that's where things can get tricky. So make sure you pay attention to that stuff. And if you have to map the whole thing out in binary, go ahead. I tend not to do that because I hate binary.